Hi everyone, my name is 𝐂𝐄𝐎'𝐒. I'm the Assistant Director at the Center for Analytics and AI Engineering at the University of Toronto. It's my absolute pleasure to welcome you all to this seminar today. Before we begin, I'd like to just remind everyone that this seminar is being recorded. If you have any questions throughout the seminar, please just type it in the Q&A box and we'll get to those at the end of the seminar. Without further ado, I'd like to ask Professor 𝐕𝐈𝐍𝐒 𝐂𝐿, our moderator, to introduce our speaker. Thanks.
Thank you, 𝐂𝐿. Good morning and welcome everyone. My name is 𝐕𝐈𝐍𝐒 𝐂𝐿, an associate professor of medical imaging, cross-appointed to mechanical and industrial engineering. It is my great pleasure to introduce our speaker, Mr. Stephen Truong. Mr. Stephen Truong is the founder and CEO of VinBrain, a subsidiary of Vingroup, which is the largest corporation in Vietnam. He has been in the AI and software industry for more than 25 years and held senior leadership positions for top technology companies in the US and Canada, including Microsoft, Honeywell, and Intel communities. Before joining VinBrain, he was the director of AI incubation and engineering, reported directly to Vice President of MSAI, Microsoft US. He has led multinational teams and key innovation initiatives such as Smart Reply or iRanker for Microsoft Office 365 and Workplace Intelligence with millions of users worldwide. Mr. Stephen Truong received BAc in Engineering Science from University of Toronto in 1989 and MBA Information Technology from University of Phoenix in 1997. He has co-authored dozen patents, white papers, and publications in top-tier conferences in NLP and computer vision fields. Today, he will give us a talk with the title Digital Health AI for Telehealth and Radiologist AI Assistance by VinBrain. Thank you very much, Stephen, for being here and giving this talk, and the floor is yours.
Thank you, Professor 𝐂𝐿. Good morning. Good morning, everyone, and good evening for someone on over the world. So today, I'm presenting VinBrain, and also more important as the U of T inside, veteran or alumni to talk about AI, which is one of the exciting topics. Even more is about AI for healthcare, which is a very humanity problem. So through the discussion, we will talk basically about two product lines. One is AI for telehealth, which is AIviCare, as long as AI Smart Care. And we have been applied that for, outbreak of the COVID and official application using in the country right now for 100 million people. We have, fast track in terms of using AI to guide the patient to the right doctor, and do prioritization emergency for, COVID patient as well as other type of problem based on, SpO2 and also how to treat them with timely fraction. The second product will be around DrAid, focusing on AI assistant for medical imaging, with been done. That this is a lack of accessibility into radiology with 60% over the world. Imagine that. So it is a huge problem space for us to tackle. And today we focusing on the mission of VinBrain is to infuse AI and IoT to improve human life and productivity. And we aim for, with the vision of a smart healthcare and smart living for anyone, anywhere, anytime, based on mobile first and also cloud first. So this is the path that we've been, developed VinBrain from the day one. So I honor to be the founder of this, company. And the mainly highlight I think in here is we able to ship the product after 1 year from, and we achieve 63 hospitals in the Q1, and now we achieve rollout to more than 100 hospitals with nearly 2,000 doctors and health staff using it. We also achieved the worldwide recognition as the winner of ACM AI Industry Award, and previously is Microsoft. So far they have 2 winners, and VinBrain fortunate is one of them. We also roll out the AIviCare telehealth, and today we already have nearly 700,000 patients in the database. So below is just the journey that we have been doing for building the core technology on the way to human and staff with a stellar team that I very fortunate and humble to share. So if you look at it, like when we roll out the DrAid for radiology and doctors to use based on AI, we realize that, okay, it's getting into 1,000 of doctors use and hundreds of hospitals. But we find AI needs data, even need bigger data. So we follow the industry trend as well as be creative in creating the AIviCare for telehealth. Is a B2C model versus DrAid as a B2B model. And we able to build a pipeline and the ecosystem with a channel for patients to connect to doctor for the right problem, including treating COVID at home. And because of that, we achieve a high volume of data, which is electronic health record. That helps to develop further AI, and based on that, we can achieve the 4P medicine, including like basically personalized for patient, predictive for disease and abnormal finding, preventive for monitoring, and notification. And last but not least is participatory, which is combined of 1 to N trial data to help the doctor to do pattern recognition based on big data. So it is a circle of ecosystem, and that will bring the best possible patient outcome. So here is the telehealth system that AIviCare that we're doing. On the patient side, we build the AI chatbot for diagnosis and assistance, so that we can get the personalization based on mobile first, deal with chronic disease, nutrition, health, psychiatry problem that patient doesn't have to be offline, which is visiting the hospital and may get COVID. So it is a way to utilize technology to enable patients can connect to the doctor easier and accessibility. And on the doctor facing side, we have medical record and historical record, so that doctor can look at the historical data. If patient have the CT scan today with a large tumor, we can refer back to the X-ray a year ago and do the alignment to find out is a sign of growing for cancer or it is beneath, which is non-cancer cell or not. So historical data are very important in treatment patient. The second is we build the AI to help medical imaging to process faster and more accuracy. It is enabled to supporting doctor and assist doctor to do a faster job and at higher accuracy. And based on the big data, we can do data analysis and add data analytics in real time, and as also forecasting certain disease or certain things for preventive and prediction. So on the research side, we're focusing on medical imaging, analysis, triage, drug discovery, genetic research. For example, like thalassemia detection based on blood tests. So this is a technology we've been using at the core. So you look at the top, like radiomics features, so feature with brightness or sharpness, and the intensity, and also statistical feature. It's hard to do by intuitive, and today doctor may do that. So what we do is we want to be scientifically and statistical to build a model so that we can help the doctor to extract those features, based on mathematical and statistical technique. And then we're using explanatory AI, which is like RADCAM++ method to debug when the model is detect the disease correct or not. For example, the RADCAM output from a model detection, based on deep learning, if they fall outside the lung, we can say that it is not really correct. So then we can go back to the feedback loop and analyze it. So this is a way to utilize explanatory AI to debug and improving the model. That labeling the data for medical image is expensive and also time consuming, because doctor very busy, and also is one of the high paid in any country. So what we did is using active learning so that we can improving the label data and cut down the cost. And the way we do that is we basically find out the uncertainty, imaging based on analysis the data, and utilize the labeling pipeline to improving that data, and then using active learning so that we continue to improving and label. And by doing that, we proving that we saving the labeling time, or basically the volume, from 50 to 68% based on different kind of disease. We also using semi-supervised learning so that we can, also improving the labeling speed. So some of it can be labeled by the model based on the average mean of the, scoring. We're using graphical neural network, or CNN, because we know that disease related can help the model to improving the model. For example, if lung opacity, model, and also combined with consolidation, we can improving the consolidation and vice versa, because they are interrelated, abnormal finding and disease. We're also using speech, assistant tool to do the speech recognition and text to speech, to allow doctor can use voice, through the microphone to correct the generated medical report directly from the model, so that we can saving the workflow and the time for the doctor to do the administration work. Based on that, we also leveraging the big data to collection all over the world, not just in Vietnam. So today the data in Vietnam about 1/3, and Europe is about like 20-25%, and US is nearly 40%. So we can achieve the generalization by doing that. And last but not least, when we bringing the imaging combined with the blood test together, for blood test extraction of the data field from the blood test, paper or uploaded, we able to need to use the OCR technology to do so. So below is the information that we did with number of models, cognitive API that we based on the cloud, the hardware that we use for training. So we use top end hardware like A100 from NVIDIA. We also their strategic partner, and we are the only 3 companies mentioned by Jensen Huang for the GTC 2021, their biggest conference, recently in October. And this is the number of hours that we spend for R&D. Next. Sorry. Okay, so let me talk a little bit about the AIviCare for COVID. So we will go through why we're doing that, what we bring the value to the community. So in Vietnam, in the wave 4, which is the worst cases happen in Vietnam so far because of Delta. So they have like nearly 500,000 confirmed that contaminated with COVID, and 80,000 been treatment with hospital, and more than like 15,000 people dead. And cases, the new cases is coming like about 5,000 every day. And we understand the urgency of that, so we build the AIviCare that's doing the like patient can upload the information through the AIviCare app, and we're able to prioritize the case automatically based on SpO2 number, like below 95%. Then we go into the urgent cases that doctor need to contact them and make the appointment with them. And we also look at all the data like respiratory rate, heart rate, and other things, so that we can help to prioritize it. So this is AIviCare for COVID that helping like bring the dashboard for analytics and also forecasting COVID spreading, so that the staff and the government can using the right staff at the right place. Patient can access through the doctor quicker than have to rush into the hospital and line up in there. And last but not least is they can also update data and vital sign information every few hours to a day. And doctor can have a comprehensive team, tool to do the video call and analyze the patient based on electronic health record. So here's the app that quickly I just want to show you, how it works, and that's what we have so far. And then this is like on the patient side, where you can see like beginning they can view the priority case, they conduct the normal cases to do the screening, and then they can look at the historical data to make the informed decision for treatment. And they can like basically pre-schedule the next call. Here's the real-time analytics dashboard that we build to help like government and medical leadership like Ministry of Health, Department of Health in the province and big city to analyze the data in real time, and also do the predictive forecasting for the spreading, so they can invest the people in the right place. This is a demonstration of how we sending the team to help to train and also resolving the COVID problem when they get spreading. So today, with launching within 3 months, we basically 2 weeks actually, we have about like 22,000 record that's been treated by AIviCare with 100 doctors using it, and we have like 1,000 of telehealth calls. So the journey that we aiming for AIviCare is objective in 2022 is 2 million plus user with more than 1 million visit count. And this is a journey that we're going to build it over time, from the time they have a healthcare problem on the way to how to using AI to find the right doctor, and then how they can get the appointment, and doing with helping from the AI to help to find the right treatment, and they can receive everything basically online for most of the time. If anything they need to do like imaging, they can visit the hospital nearby and upload the image into the app. And we can expand further in drug delivery, as well as working with the insurance company, so that we can launch a product together with them. So with the DrAid, I'm going to say the same thing, like why we're doing it and what use case we try to solve, and what the machine learning, how we build the product, and what the shipping criteria. So basically, that like 60% of the people in the world that lack of medical imaging services. That's equivalent to 4.7 billion people lack of access. And in Vietnam itself, is instead of 8 radiologists per 100,000 population, we have only 3 radiologists. So having AI to help to do the screening and making doctor more efficient and improving the accuracy, it is the design and it is the need. Second, we also learning that like doctor waste a lot of time on paperwork. So that's what when we do the DrAid, we also do automated generate medical report, so that they can reducing the time to consume to write a report. And doctors just do like, simple correction, if any. And then we also realize that about 30% radiologists may miss the abnormal finding. The problem is medical imaging is a complex field. And that's why, it's been years of building like medical imaging, standardization on image, and all kinds of equipment, and huge investment because it's complex. But even we got all of those, there's a change that is still miss like abnormal finding when you're reading the X-ray or CT. So and that will lead it to more serious problem if it got missed, including possible of fatality. So the DrAid is today building for radiology and expansion for thalassemia detection, which has belonged to the methodology. And then we go deeper into oncology for liver cancer and rectal cancer. So when we doing the DrAid, we do the A/B test, and it's proving the accuracy with and without AI. With the same doctor, the same imaging is improving from 9 to 25%, and time saving is about 1/3, and its goal is for better patient outcome. So you can look at this for multiple, work cases. So with chest X-ray, we do like classification and segmentation for the lesion abnormal finding. For the MRI, we're focusing on segmentation and registration because during radiation treatment, rectal cancer can be run over like 3 to 6 months. So during that 3 to 6 months, the weight of the patient may change. So that's why we have to use registration, which is one of the top technology to align the tumor together so that we can ensure that the calculation of the size of the tumor is correct. And then when we go into the liver cancer, we also apply of a classification to detect the problem based on the 4th stage of the CT of the liver. For the blood test, we use it for thalassemia, and we already mentioned about the text-to-speak and speak-to-text to correct the medical image. So I also want to talk briefly about the machine learning workflow. So building a product is fairly complex compared to just develop the model in the lab. So beginning, you will go with the step of model requirement, which is what is the problem you like to solve. Whether you want to do like liver cancer or you want to do abnormal finding for, lung nodule and mass, which is lung lesion. And then you will starting the process to do data collection so that you can use it for training. But data collection then is important to do data cleaning so that you can clean the image is blurred or not the size you want, not the pixel that you want. Like today we're using 512 to 512 size pixel, on the X-ray image. And after you qualify the data cleaning, you start building the labeling process. So before you do the labeling process, you have to define, the way to interpret it, the image. So VinBrain, fortunate, working with Stanford from the day one to define those. And we also combine with the top doctor radiologist in Vietnam so that we can get a standard on the description and definition of abnormal finding and DC. Then we're going to build a process to do the labeling. I will go through that in the detail, but the process has to be eager to make sure that data labeling is high quality. And then we will do either deep learning, which is automatically do based on big data to do feature engineering, or some of it we have to do traditional machine learning by do feature engineering by find out the feature to extract and also suppress and filter out feature that causing the noise for the model. For example, I mentioned earlier about the radiomic feature, intensity, texture, things like that. And then we perform the model training, and then we have to do the validation and test sets to evaluate. So test sets must be hidden data sets that not in the training set. And we keep iterate through it until we find that it meets the shipping criteria. Then we ship it. So we running more than 200,000 hour of development and able to get the model. And when we deployed it into the cloud, we choose cloud as a base so that we can achieve faster deployment and can be accessed from anywhere. And we build a feedback loop for monitoring the false positive and the false negative. So we continue to iterate through the process. Here briefly how we have done in data collection, data cleaning, and labeling. So we have nearly 1.4 million medical image for the X-ray, And then, for example, and then we have used, radiologists to do the labeling and go with at least 3 rounds to make sure it's high quality. And we achieved nearly like 400,000 imaging that labeled by 3 radiologists. And we have worked with 50 plus like radiologists with them have at least 5-year experience to do the labeling first. So here is the in-house labeling process. So when VinBrain applied scientists, the one that's building the model for AI, have a request, we go through the product management to run the project of labeling and put into the queue. We go through the, assign, and partitioning the data to allow the labeling process. And if they agree, then we can use it for training. If they disagree, we go through the 3rd round or supervisor. And, the supervisor will guide them, like, this group of doctors to do the label. So after we do that, we got the collection of the label data and sign up based on, confusion matrix and F1 score to evaluate it. And then if we qualify, set, that means we improve more than in the past, then we pass it to, basically apply scientists to develop the model further. So we also apply big data. So you can see today the way we train, we're using pre-trained model or transfer learning. So with the 1.4 billion image from, Facebook, particular Instagram, we train and transfer the feature extraction. And then when we but imaging from normal image is different than medical image. So we do the transfer learning into our, 1.3, cell supervised learning imaging, for example, X-ray. And then we do another transfer learning with supervised learning, that been labeled by doctor. And then we're going to build particular model for specific problem. Example, for COVID, we do with 21,000 imaging for training that model with the positive cases. And COVID, we have the biggest, as far I know, we have the biggest, number of X-ray of positive COVID in the world. So that's the way we do the development of the model. On the right hand side, you can see how we've been developed with student and teacher model for the transfer learning. And the RAP CNN, which is RAP to relate it the DC together so that we can improve the model. So the product shipping criteria for any product we ship, like say, for example, for DrAid, offline evaluation by hidden test have to achieve 85%. And then we can move to the next step, which is do an A/B test with doctor, with the same image with doctor and no doctor. With doctor with AI and doctor without AI, and it must improve at least 5%. Then we allow to do a trial with user acceptance test in the real hospital environment. So so far today we already achieved specificity 95% for our 21 abnormal medical finding. Sensitivity is above 90 and F1 score also above 90. And with the medical image, when we ship the DrAid at the beginning, we try with 6 experienced doctors, run 2 rounds on 10,000 X-ray. 1 round with AIviCare and 1 round without doctor, and 2 weeks apart so that they don't remember what they did before. And then we compare the result because we already have the round 2 set to evaluate, the data. and the route to set based on, like a medical record to confirm they are truly having those disease. And CT scan is the golden standard for X-ray. And with the user acceptance test, we must achieve more than 70% satisfaction. So when we're doing that with 10 days consecutive, and every day we collect the SAT index from doctor, and we try with nearly 800, more than 800 imaging from 5 separate different hospitals, we achieve 84% satisfaction index. Here is the way we integrate the AI into our DrAid. So you can see one is doing without the DrAid, we're just using API. So image come from the imaging machine, the DICOM file. We have the PAC server from non-DrAid. We send the image to the VinBrain cloud and the API, and the AI come back, and then they can display in PAC server like GE or Philips or Siemens, and then the data, the conclusion will come back so that we can improving the AI. And the report we generate and view it in the PAC viewer. With the DrAid, it's similar, but DrAid will be the lightweight of PAC system. We call it AI PAC cloud. So it's not desktop based, but it's more like web based, and everything run from the cloud. Here's a quick snapshot of today where our customers, so we have more than 100, precisely 111 hospitals using our DrAid today. We have nearly 2,000 radiologists and staff using it, but out of that, it's about 70% or 65% radiologists using our DrAid. We have expand all of the hospital into 33,500 hospital beds. That's the volume of all the hospital that's been using combined, and approximately those hospitals with 30 million visits per year. So this is the illustration of the DrAid for COVID. So we involved with the COVID from the day one, which is April 2020. We already collect the data and develop the model. So today we got the Ministry of Health in Vietnam put us as the first recommended AI for treatment COVID across the nation. So our product will be included in the protocol of treatment COVID. And this is an illustration of how we, go and helping the pandemic. And finally, thank you so much for your help, and I'm looking forward to hear some questions. Thank you.
Thank you very much, Stephen, for a great presentation. A lot of interesting things going on. Congratulations for so many successful projects. Okay, I would be happy to take questions and present it to Stephen. Okay, let's see. I think there is one question regarding the no PAC scenario. How are the AI predictions delivered? Are they delivered by standardized DICOM objects like PR, or as DICOM images?
So the input to the AI system is a DICOM. So if imaging is already electronic or digital imaging machine, then it will be output DICOM as a standard. If the imaging is output and got printed out like hard copy, then we using the camera on the phone to taking the image. And then if we evaluate the image is the requirement for quality, like in terms of pixel and blurriness and the sharpness and things like that. Then if we convert to become one of the DICOM file, then it will be also input into the AI system as DICOM for AI to interpret it.
Thanks, Ismail. There are a couple of more questions. One is, what first inspired you to pursue this? Which engineering science discipline did you choose?
Yeah, so basically, when I was in Microsoft, my background is, and also the company do more about productivity and enterprise software. But then, when my mom got the stroke in Vietnam, then I went back and take sabbatical and helping her during the stroke. I realized that many patients, including children, come to the hospital and line up like hundreds of people, like thousands, and waiting for to see the doctor. Then I realized that what next purpose in my life. So that's the reason that lead me to go back to Vietnam and form VinBrain and doing like more humanity direct related problem, which is healthcare. And I think that healthcare have a great opportunity to improve, not just for Vietnam, but over the world. Technology is adopted, at least from my humble opinion, is adopt slow in healthcare. So I think because of its slowness, adoption, from the technology, it is a great opportunity, and it is a big space for us to improve and enhance. Like using AI to help the doctor to do better job, and to help the hospital to do better planning based on real-time analytics and forecasting, and help drug maker to know what the investment based on data when they develop the new drug.
Yes, Simon. I have a question myself, and so my lab is at SickKids Hospital, and we work on similar projects in terms of deep learning and radiomics for medical imaging. One of the bottlenecks for us is how to make the data, especially the images, AI ready, and that takes a lot of resources in terms of not just collecting data, but as you said, cleaning it up, pre-processing. And because we get the data from SickKids, it takes a lot of time and energy and resources. I just wonder, in a platform such as yours that deals with a lot of heterogeneous data coming from different hospitals in different probably formatting and settings, how do you handle that? And is there a lot of manual intervention, or is it fully automated?
It's a great question. So when we do the AI for medical image, and even like different machines have a standard for the output, like today we have DICOM as a standard. The quality and the configuration of different machine and different manufacturing causing some bias. It's biased by the machine, it's biased by the doctor that familiar with that disease, it's biased by the hospital that have more epidemic data. So the way we solving it is we believe in data-centric and big data. So, and then we also believe in standardization of the input of preprocessor. And we also standardize on the way that we interpreted the imaging. So all of that have to predefine, and we need to build a labeling tool, which is proprietary for ourselves to speed up the process of labeling and also analyze the data. Now, we realize that that's not enough and not fast enough. So we build and utilize active learning and supervised learning so that we can achieve 50 to 70% imaging can be labeled by machine rather by human. But human have to be the teacher first. And that's why I shared earlier about the student teacher model that we been of the pipeline that we've been developed. Now, when we ship it out to validation, AI needs to be validated early and get the feedback loop. So we have to build a very rigorous process to do the feedback loop and analyze constantly about the quality of AI so that we can do adaptation learning. And when we roll out to the new hospital, we also quickly retrain the model and improving the model if the quality is not enough. So I think the bottom line comes down to is standardize what you need to do so that we don't run into the hiccup later when it worked well for one hospital and it worked terrible for the second hospital. Second is collect a lot of data and also do the data cleaning process fairly well, and also using technique to do semi-auto label, and then use human as the driver to get the first good quality model and use that model to relabeling the new data. So it's an iterative process is the second tool. And the third is the rollout and validation early and monitoring and feedback loop so that you can improving the model. You also need to work with different university research so that we can build a good core technology and new technique. For example, with University of Toronto, for Stanford, and recently we signed with Harvard Medical School and also with UCSD, University California of San Diego.
Thank you very much, Steve. One more question. Can you please elaborate how would you deal with the privacy issue related to the medical information?
That's a great question. And this is mainly doctor and hospital leadership director asking. So the way we do that is, I think if I go back to the one of the slides that we have. So right here we have a, too fast. So we have VB1 box. So the VB1 box, when we install in the hospital inside their network, is supposed to do the PCI, BII, the personal identification data, extract that and take it out, wipe it out, so that the data go into our VinBrain doesn't contain BII data, and they just only stay within the hospital for that patient. So when we train, because you don't need this image belongs to Stephen or belong to John, so those data can be extracted. We only bring the data with the image, such as demographic data like age, which is important, and maybe sex and things like that, but that have nothing with BII. So we have to filter out those data, and then all of the AI coming back is presented in their environment, so they can correlate it back to the patient.
Thanks. So can I ask, because we have a couple of more questions, do we have time to ask a couple more?
I think so. Just about 5 minutes. We have to wrap up in 5 minutes. So.
Okay. So one question from Yucheng is, which contrastive learning model did this project use? Is that Dino according to the picture?
Sorry, what the?
Dino, D-I-N-O. So the question is, which contrastive learning model did this project use?
Oh, so we using like the model that we're using for deep learning, like RegNext, and so when we do like transfer learning, okay, I will go to that slide. Here you go. So when we do from the feature extraction from RegNext, right, and then we go to the RegNext, which is our model, and this is the model that we do for feature extraction. And then we're using the RapCNN for related DC, so that we can improving the model. So these are the very much like the model that we're using from the feature extraction and also for the, related DC.
Okay, and I guess probably one more question. Would an AI, this is from Michael, would an AI analyzing system like DrAid also provide the same quality of analysis if brought on premise instead of cloud-based in a dedicated data center? And which hardware requirements would you have?
Yes, so we the way we build and deploy AI, we put into Docker. So each Docker is running on either CPU or GPU. And because right now the GPU getting a chip as CPU, and with the NVIDIA latest technology, so we make the decision that our model runtime that's been optimized after the Python is converted to C++, and we're running that on the Docker. And we can take the Docker and we put it into the server that can run inside the hospital if they need on-prem. So the company recently we signed with Forum Health in US for utilize our AI. They going with that model. They cannot go with the cloud because like certain regulations don't allow the medical imaging, which is like basically like health record leave the hospital. So then we go with the on-prem model, but the quality is the same because we're using the same model running. And the scenario that we've been using is one is with like running doctor running the workflow independent, and then AI run in parallel. If we find out that any DC that got misdiagnosis by doctor, AI can inform them, and then they can call the patient back for further analysis and study, like could do CT scan after they do the X-ray, and if it got missed, like say noodle got missed and confused with like other type, could be like opacity or consolidation, then they can call back. Or fracture of the bone that got fracture but it got missed, because it's easy to get missed with fracture when someone coming and just say I have pneumonia. So doctor will be more likely biased by the symptom described, so they're focusing on analyze the image based on what patient saying. But they forgot that maybe the patient fell and got like running bicycle and fell a week ago and got broken bone, but he not even noticed that. So this kind of thing that AI is very not subjective but more objective, and that will have the the hospital and to improve, the patient outcome.
Thank you very much, Steve, and thank you very much for great presentation. I'm going to pass it over to you, Sumaya.
Thanks a lot. Thanks, Stephen. Thanks, Professor Khalvati. This was a great seminar. I personally enjoyed it a lot and very inspiring too, very needed in the whole world, actually, not only Vietnam. I'll just put in the link for our next seminar for those of you who attended this seminar and are interested in that. Please feel free to register for that, and we hope to be in touch. Thanks a lot and have a great day.
Yeah, thank you. Happy New Year and stay
too.
safe and well. Thank you, everyone.
Thank
Bye.
you. Bye.